let's look at these next group of problems. Notice in the next group of problems, we're told to simplify each expression and write all answers with positive exponents. That's a subtle point to make, but very important. Well, let's look and see what they want us to do. Let's start with problem number A. Well, notice in A, we have 3 to the 1/2 times 3 to the 1/3. Notice the important part is that the base, the 3, matches. Remember, if the base does match, the base will stay the same. It will stay as a 3. The base always stays the same. The question is, what do you do to the exponents when you are multiplying? Well, notice when you're multiplying, remember the rule was that you add exponents. So we'll take the 1/2 plus the 1/3. But these exponents aren't just any ordinary exponents, they're fractions. So how do you add two fractions? Well, we need a common denominator between the two. Well, we've got a denominator of 6 and a denominator of 2 and a denominator of 3. So the common denominator would be 6 that we would want on both of these. Well, on the first fraction, we already have a 2, so it needs to get multiplied by a 3 to get the 6, so that will become 3 out of 6 for that first fraction. The second fraction also needs to have a 6. Well, it's got a 3, so it needs to get multiplied by 2, and that will turn into a 2 out of 6. Then when we go ahead and add our fractions, we have a common denominator now, so the denominator will stay the same. It will be a 6, and we can just add normally across the top. And 3 plus 2 will give us 5. Now the question is, what is this 5 over 6? This 5 over 6 is the exponent on our base 3 that stayed the same. So it gives us 3 to the 5 over 6. Notice we are good because this exponent is positive, so we can just leave it just like this and we are all done with this problem. Let's look at another one. Let's look at problem B. On B, we have x to the 2/5 times x to the negative 1/3. Again, notice that the bases are the same, that they're both an x. So when we multiply, the base will still stay the same. It will stay as an x. Again, the question becomes the same one that we had in the last problem. We have an exponent of 2/5 and an exponent of negative 1/3. What do we do to two exponents when we are multiplying? Well, we add the exponents. So we have 2/5 added to a negative 1/3. Again, we're adding fractions, so we need a common denominator of, in this case, the common denominator between 5 and 3 is 15. Okay, well, this first fraction has a 5, so to get it to turn into a 15, we're going to have to multiply it by 3 on the top and the bottom, which will give me a 6 on top. The second fraction already has a 3 on the bottom, so it needs to get multiplied by a 5 to get the 15. Then we've got to multiply the top by a 5, which will give us a negative 5 on top. We've already got the negative written for us. Now that we have a common denominator, we can go ahead and add. Well, what is 6/15 plus negative 5/15? Well, that becomes a positive 1/5 over 15. So that's our new exponent. Once we have added the two exponents, we get 1 over 15. And that is a positive exponent, so it can be left that way. Now, I do want to point out that you can, if you want, rewrite this. Remember, whatever's on the denominator of your fractional exponent is your root, so this can be rewritten as a 15th root of x to the, well, the exponent here is just a first, so it'd be x to the first power, which is just an x. So we can write this as x to the 1 over 15, or we can rewrite it as the 15th root of just x. Either one of these are fine. They are actually equivalent equivalent answers. Let's look at problem number C.